Hello chemistry students. So we're going to start balancing redox reactions. The first method we're going to go over in this video is the half reaction method. Stay tuned for a second video that will go over the other method that's balancing using oxidation numbers. Both similar, one faster than the other, and you'll need to know both of them. So let's look at our first example. Also a reminder that this goes hand in hand with a posted lesson summary with steps and other examples, so you can follow along with that posted document. Okay, so this is our example. So we're asked here to balance the following, so this reaction, this redox reaction, and it occurs in an acidic medium. So that's important to note, it occurs in an acidic medium. Okay, so our first step, right, these steps match what's posted online. So our first step is to write the unbalanced equation and assign oxidation numbers to all of the entities. And we practiced doing that already in previous lessons, so let's do that now. Just rewrite this. And as we're writing along, or at the end, we can start to assign oxidation numbers. Okay, states should be written. They especially play a role when we're identifying if a reaction is going to occur or not, but to save some space here, just know that it is important, but I'm not going to do that right now.
Yeah?
Okay, so this is the reaction, and now oxidation numbers. Okay, we're looking for clues here. So I'm going to do oxygen first. Oxygen is going to be, we know that's going to be -2, right? There are 3 of them, so that would contribute a total of -6. But it has to have that -1 charge because this is nitrate, so that means oxygen has to be +5 here. Okay, so let's just finish off oxygen here as well. It's -2. Now, because it's -2, this will contribute a total of, in this sulfate, it will contribute a total of -8, but it has to have a overall charge of -2. So that'll give sulfur a +6 charge. Okay, oxygen here is -2, and therefore nitrogen, for it to have no charge, has to be +2. Okay, so here Cu2+, well, it already has oxidation number here, right? Its charge is given, so that's just 2+. Now we're left with this. So when this happens, when you're left with without an oxygen present to give you a clue, or without, in this case, a given charge for an ion, you're going to go with the most common charge. Okay, and it should work out. So sulfur would have then a -2, which would mean that copper has a +2. So we figured that out using a periodic table. Okay, so now we've written the unbalanced equation and we've assigned oxidation numbers to all entities. So next step. Okay, we're going to identify and write the unbalanced half reactions. Now I will begin to write them down here, but I do need to refer back to the previous slide to show you how I figured this out. So let's look at the copper. Copper 2 sulfide, to be exact. Now this has changed. So this half reaction here, if we're looking at just copper, yes, it has also sulfur is involved in this half reaction as well. So it's we're going to include all of this in our half reaction, but look at the charge on copper and sulfur, see if that has changed. So copper has gone from +2 to +2, so nothing's changed there. Now sulfur has gone from a -2 to a +6. Okay, so we're going to keep that in mind. Now nitrates in nitrogen in NO3 and nitrates to NO, that could be your other half reaction. Let's see if oxidation numbers have changed here. So nitrogen has gone from +5 to a +2. So there has been a change. Okay, let's see if we can identify what kind of change has happened. So nothing's happened with copper, so we can ignore that, but sulfur has seen a change. It's gone from -2 to a +6. So it's become more positive. It has lost, we can say it's lost about 8 electrons at this point. We'll deal with the electrons later on, but we know that it's lost electrons, so it's lost electrons here. Now if this is a true redox reaction, it is a question, then we would have seen a gain of electrons in this other half reaction. So nitrogen has gone from +5 to a +2, so it's become more negative, meaning it has gained electrons. So that should have happened, gained electrons. And we'll worry again about how many it's lost and gained in a following step. Okay, so here we are now, copper to sulfide, producing copper and sulfate. Losing electrons means it's oxidized, and gaining means it's reduced. Remember, Leo the lion says grr, right? Lose electrons means oxidation, gain electrons means reduction. So we can write these half reactions down in our next step. So copper to sulfide. This half reaction, I believe that was the oxidation. Yep. Okay, so CuS produces a copper ion and sulfate at a -2 charge. Okay, we can just say oxidation here. The other half reaction involves nitrate. Okay, and we can say that has been reduced, or it's a reduction reaction. Making sure I'm okay here. Gained electrons, yes. Okay, that's it. Second step is now done. Third step. So here it says to balance atoms and charges in each half reaction. So this is a bit longer of a step here. We're going to use H2O to balance oxygen. So we're going to just plop in H2O for either side, for the side that needs oxygens, and we're going to add hydrogen ions to balance hydrogen for whichever side needs the hydrogens. And finally, the third part of this step is to add electrons to balance all the charges. Okay, let's see if I can fit this all in this one slide. So let's start with oxygens. Okay, so CuS 4H2O. I'm adding 4 H2Os here. I'll go back to show you why that's happened. Just kind of jumped into that right now, but I'll go back to show you that. Okay, so stepping back, we're balancing oxygens right now in our oxidation half reaction. We can see that on the right hand side we have 4 oxygens, and on the left hand side we don't have any, so we're going to add 4 oxygens to the left hand side, to the reactant side, and we can do that by adding 4 waters. So there are 4 waters. Okay, now let's analyze the next one before I just jump into it. So on the left hand side of our reduction reaction we have 3 oxygens, and on the right we only have 1. So we're going to make up for this missing 2 oxygens, and we're going to add 2 water molecules on the right hand side of our reduction reaction. Okay, so it looks like okay, and we're done balancing oxygens. Next, we're going to balance hydrogens. Okay, so we balance hydrogens by adding hydrogen atoms. So we can just look at what we have balanced so far, and we can see that, look, we have 8 hydrogens on the left-hand side, 8, and none on the right-hand side. So let's add 8 to the right-hand side. So CuS, 4 waters, okay, and we're going to add 8 hydrogen ions right here. So that's the new part. Okay, continuing now, looking at our reduction reaction, we have nitrate, we have nitrous oxide here, we have 4 hydrogens on the right hand side and none on the left, so we're going to add the 4 to the left. Okay, so underlying here, the 8 we've added to the oxidation side, to the oxidation half reaction, 4 to the reduction half reaction, and we've now balanced oxygen and hydrogens. So now the next step is we're going to balance charges, and we're going to add electrons to the side that needs it. Okay, so should have enough room here. Okay, so electrons with charge. Let's do the first one. before we get into this, before I just jump back into it, let's analyze. See what we're looking at these two. So we're going to analyze these two half reactions. Okay, on the left-hand side, copper 2 sulfide, water each have no charge. Okay, so there is a 0 charge in this end. And copper ion plus 2, here we have sulfate. This looks like a plus, but it's minus. So let's correct that, make sure that's clear. Okay, so 2 plus 2 negative plus 8 hydrogens, where each one has a positive charge, means that this side, change the color of the pen here. Now let's eraser. Here we go. Okay, so this side has a 0 charge, and this side has a plus 8 charge. Plus 8. Okay, let's analyze this other half reaction. So here we have a -1 and 4 positives, so that's going to give us a positive 3 charge. And here we have no charges at all, so it's a 0 charge here. So we're going to need to then, to fix this, to balance out the charge for our first reaction, our oxidation reaction, we're going to need to make sure that this end will eventually equal 0. So positive 8 plus an extra 8 electrons will give us that 0 charge. Now that side is balanced. We'll rewrite this here. Here now on our reduction half reaction, this side is positive 3. Right, this side is 0, so we should add 3 electrons. So we're going to add 3 electrons to this end, so that each side has the same charge. Okay, so I'll rewrite that. Okay, so those are those 8 electrons. And finally we have our reduction half reaction, right, plus the 3 electrons we needed to balance that out, and just rewrite the rest of it. Good. That's it for your third step. Your third step does have 3 smaller parts to it, so it's probably one of your longer steps, but you're done that. Okay, step 4. Now you're going to multiply each half reaction by an integer such that the number of electrons will cancel out. Okay, so here, let's go back to analyze what's happening here. So here, let's think about what's happening. You have your oxidation reaction at the top, so you're losing 8 electrons, your reduction is gaining 3 electrons. We know that the number of electrons that are lost has to equal the number of electrons that are gained. So whatever goes in must come out. And here that doesn't match. Look, we have 8 here being lost, 3 being gained. So we're going to have to find the lowest common multiple between the two. Now I've numbered these reactions for a reason, so I can keep track of what's going on as I multiply by a multiple. So I'm going to take my first reaction, this is the oxidation, and I'm going to multiply that by 3. I'm going to take my second reaction and multiply that by 8. That'll give me a lowest common multiple of 24 electrons, which will allow me to then cancel them out. Cancel the electrons out. Okay, so now this means I'm going to take 3 and multiply by everything that is in the first reaction, and I'm going to take 8 and multiply by everything that's in the second reaction. So bear with me, I'm going to write all that down. So 3 times everything, so it'll be 3 CuS, and it'll be 12 H2O, and so on. And we'll do that for the second reaction. This is, I have an eraser somewhere here. That's it. Okay, good, done now. So we have accomplished our goal of making sure that the electrons that are lost are the same number of electrons that are gained. Look, we've lost 24 electrons and we've gained 24 electrons here. Now these charges are balanced and we're done with step number 4. Step number 5 says to add the half reactions and cancel anything that appears, all entities that appear on both sides. So all we're going to do now is take these two reactions, add all the reactants, add all the products, and go crazy canceling. So I'm not going to rewrite these two now balanced half reactions. I'm just going to go ahead and add them all, and you'll see it'll look a bit long and messy at first, but it'll cancel out. I'm going to change my pen color as well. Okay. Ran out of room there, but I'm just continuing at the bottom. This is just an NO. Okay, done. Now I have to analyze both sides. Okay, and here's where I'm going to change colors so you can see what I'm going to cross out. Okay, so let's start off with copper 2 sulfide. So do we have copper 2 sulfide on the other side of the reaction? We don't, we're going to leave that alone. We have 12 waters on the left, and we have 16 waters on the right. Okay, well we can cancel a lot of that out. So 12 is completely canceled out. 16, not all of it is, right? 16 minus 12, we still have some water left. We have 4 water molecules left. Nitrates, do we have any nitrates on this? We have 8 on this side. Do we have any on the other side? We don't, so we can leave nitrate alone. And we have 32 hydrogen ions on the left. Well, yes, we do have some also. We have 24 on the right. So all of these 24 are gone, but not all of the hydrogen ions on this side are gone. We're going to be left with 8 hydrogen ions. Okay, now what should cancel out, and there's self-checks built into this. See, if you don't have the same number of electrons on both sides, then you've done something wrong. You want to go back to your previous step and fix that. So 24 electrons can cancel here because there are 24 electrons on the other side. Good, so now you've canceled out everything you can cancel out. All you're left to do now is just write your final answer. And we can do that in a different color. Okay, so we're going to rewrite this, and we see that we have 3 CuS plus 8 NO3, right, plus 8 hydrogen ions, right, 3 copper ions, 3 sulfate ions, and 8 NO. Okay, I'm seeing, oh, I almost forgot 8 NO, and we have 4, I knew I was forgetting something, 4 waters, 4 H2O. Good, so this is our final answer. Now I want to point out something. At the beginning the question said that this solution exists in an acidic medium. So whenever it says that, we would be done at this stage. There is another step, a 6th step. So it says 4 reactions that occur in basic solutions. This question did not say basic, it said acidic. But if it were basic, we would have to add hydroxide ions to either side that has hydrogen ions present, right? If it exists in an aqueous solution that is basic, then you have an abundance, therefore, of hydroxide ions, which would neutralize all of the hydrogen ions present in your balanced redox reaction. So you have to show that. But because this is an acidic solution, your answer would end at step 5. But I didn't want to leave you with just that. I wanted to come up with a scenario now. So if, I think it's in our next stage, next step, next page. So if this were a basic solution, then we would follow step 6. So this is not the case, but I'm going to pretend it is. So all we're gonna do now is just a simple two-step part here. We're gonna rewrite our answer, and we're going to add hydroxide ions for wherever we have on either side, wherever you see hydrogen ions. So on the reactant side, we have 8 hydrogen ions. Let's go back to verify. Look, we have 8 hydrogen ions right here. So that means we're going to add 8 hydroxides. It is a basic solution after all, and we do have hydroxides to add. Okay, now your other side of the equation, before I continue writing, let's analyze that. Does that have any hydrogen ions at all? No, it shouldn't. Remember, we cancel those out, so there's nothing on the other side, so we can just rewrite the other side as is. Get my eraser here. Okay, 8 I know plus 4 H2O. And 8 hydroxides. Okay, so since you added 8 hydroxides to the left-hand side, which you do to the left-hand side, you have to do to the right-hand side, and you therefore have to also add 8 hydroxide ions to the right-hand side. Okay, now something happens here. Look, you have 8 hydrogen ions and 8 hydroxide ions. They neutralize. So our second step is, let's simplify this, and show that neutralization, that formation of water. 8 hydrogen ions and 8 hydroxide ions produce 8 water molecules. I'm just rewriting now the rest of it. Okay. So we're going to look at now both sides, and we're going to see what appears on both sides of these reactions, or of this reaction. Our reactant side has 8 water molecules, our product side has 4. So let's cancel. All 4 water molecules on the product side are now cancelled. Not all 8 are on our reactant side. The 8 becomes a 4. Because 8 minus 4 is 4, and we can now rewrite our final answer. If it were in a basic solution, will now then look like this. And now that's your final answer in a basic solution. So that's it for balancing a redox reaction using the half reaction method. Another video will go over how to balance using the oxidation number method. I hope this helps. Post any questions so I can answer.